We are now looking at lesson C2, discovering more rules with exponents. The I can statement is I can determine the properties of integers and exponents by using prior knowledge and examining patterns. So if we are looking at this, today we are going to look at some different patterns with our exponents. You should be following along in your notes, and the key thing that I would like you to add at the bottom of this page is a couple of things that we always need to remember. The first of those that we talked about earlier this year is that any number, doesn't matter what that number happens to be, if we divide it by 0, 7 divided by 0, -2 divided by 0, all of these will always be equal to undefined. So remembering that we can never divide by 0. It is undefined. Whereas, the other thing we also want to add to our notes is that if we take 0 and you divide it by any number, that will always equal 0. If I take 0 and divide it by 4, I get 0. If I take 0 and divide by -3, if I take 0 and divide it by 1.8, all of those will be equal to 0. So making sure you know the difference of those and you have that in your notes. Now, what we're going to do is we're going to use our calculator possibly, and even just our facts that we know. 2 to the 4th, if you were putting that in your calculator, remember how you put that in? You're either using the caret key to the 4, or you might be using 2, and then some of your calculators have an xy to the 4th, gives you 16. You should have memorized 2 to the 3rd is 8, 2 to the 2nd is 4, 2 to the 1st is 2. Now, before we put in 2 to the 0 in our calculator, I kind of want you to notice what's happening each time as we go down here. 16 divided by 2 gives us 8. 8 divided by 2 gives us 4. So if we continue with that pattern, check it in your calculator, 2 to the 0, it comes out to be 1, which makes sense because 2 divided by 2 is 1. So now we're going to put these as fractions, not decimals, no decimals. So if you use your calculator, most of you in your calculator, it comes out 0.5. But again, we're going to take 1 and divide it by 2. So 1 divided by 2 is 1/2. This next one, again, we're going to divide it by 2. 1/2 divided by 2 comes out to be 1/4. This one is going to be 1/8. And then our last one is going to be 1/16. What I would like for you to do is try this next column. Again, we're going to start off by putting in our calculator 3 to the 4th, which gives us 81. And what I want you to notice is what, as you look at these columns, is that the 16 for 2 to the 4th and 2 to the -4th, that these are reciprocals. So when we are looking at this, this is our reciprocal. Kind of hard to write on that small area. 2 to the 3rd and 2 to the -3, 8 and 1/8. 2 to the -2 and 2 to the 2nd, 4 and 1/4. Same with these two. So we have reciprocals all the way. That kind of helps us when we do this next column. So 81, we know 3 to the 3rd is 27. 3 to the 2nd is 9. 3 to the 1st would be 3. When we put this one in our calculator, again, we're dividing by 3 going down. 3 divided by 3 is not 0, but 1. And then if we notice, reciprocals. So we should have 1/3, 1/9, 1/27. Well, you just heard the buzzer go off. So what should the last one be? We should have 1/81. I would like you to pause the video at this point. So just by clicking on it, and try right now to fill in that last table, and then when you're done, when everyone has filled it in, turn the video back on so that you can see how you did. You can now see how I filled in my table. Hopefully yours look the same. Notice I highlighted the bottom of each of these. The key thing that I want you to notice about all of these negatives in each one of these columns is that the negative exponent in no way gives you a negative value. The negative exponent is not a negative number. All of those were positive, not a negative number. What the negative exponent does is it makes the reciprocal. And reciprocals have the same sign. So, it's saying, if we look at that first table, what pattern do we see? Well, we kind of discussed it as we were filling it in. Each number is divided by 2 as you go down the table. If you wanted to think of it as going up the table, if we were looking at going up the table, if you're going up the table, and that means from starting at the bottom and going up, you would be multiplying by 2. Negative exponent just means reciprocal. Reciprocal is the key thing. Please make sure you write it down many times to get it in your brain. If we look at the second table, what would we say as we go down the table? We are dividing by 3. If we go up the table, we are multiplying by 3. The negative exponents are reciprocals. As you look at this last one, pause the video and see if you can write your pattern again. And when you're done, we'll unpause it and see what I have written. So again, going down the table, the numbers are divided by 10, going up the table, and as we look at that, our exponents are always, as we look at those, reciprocal for our positives. So I want you to notice, looking back at that table, at all the zeros. So looking at the table, we had 2 to the 0, which you had equaled 1. We had 3 to the 0, which you had equal 1, and we had 10 to the 0, which was equal to 1. So it says, what do you think we can say about any number to the 0 power? And here is our key thing. Any non-zero, this is key, any non-zero number to the 0 power will always be equal to 1. The reason you can't use 0 as a base cannot be the base is that if we take 0, if we think about this, as we look at our pattern up above was 2 to the 0 equaled 1. We could say 1 to the 0 is equal to 1. And if we put 0 to the 0, we're saying it should be 1. But that's not possible, because if we think of this one is not possible, just thinking about our pattern, because if we think about looking at 0 to the 3rd power, we know that's 0. 0 to the 2nd would be 0. 0 to the 1st would be 0. So here we'd be saying that 0 to the 0 equals 0. And it can't be both 1. So 0 to the 0 cannot equal 1, and 0 to the 0 cannot equal 0, cannot be the same thing. So we think of 0 to the 0 Remember, we cannot divide by 0 as being undefined, same as division by 0. So what you are asked to do right now is to practice these next ones using our rule. What did we say? Anything to the 0 power equals 1. So I'm going to do the first one. 5 to the 0 is 1. Please pause the video right now and do the next 3, and then we'll look at the bonus. As you look at that bonus, it says, and if you notice the other ones, they should all be 1s, because anything in that whole parenthesis to the 0 is 1. This actually means a negative 1. So if there's a negative out in front, that means negative 1 times 4 to the 0. So the negative 1 times 4 to the 0 is 1, and this would be equal to negative 1. So you need to be careful for that as we do our homework. So negative exponents, we want to look for a pattern. What we are going to be looking for is a pattern that we've just talked about that we can say works with any negative exponent. So here are the numbers, and are there any numbers it doesn't work for is what we want to look at. So if we're looking at a power with a negative exponent, so a power with a negative exponent means that we are going to take a look at the reciprocal of the base. Simply the reciprocal of the base. So if you have 3 to the negative 2, we're going to rewrite that because this is over 1, so we're going to put 1 over 3 to the second. That gives us 1 over 3 to the second is 9. If you're asked to leave your answer as a power, this is your answer as a power. If it says simplify, this is the simplified answer. So there's kind of some different ones in your homework that you need to look at. As we are taking a look at each of these, what I would like for you to do first in your homework is always rewrite it with a positive exponent. So if we are looking at this, first we rewrite it, we put it over 1 as 2 to the second, which then we would put 1 over 4. This is our answer as a power. This is simplified. 1 over 3 to the 4th is equal to 1 over 81. This is over 1 over m to the 6th would be our final answer. Here, when we have that negative exponent, we have to take the reciprocal of 1/7, which is 7 over 1. It is now to the second power. Notice when you take the reciprocal, it changes. So we now have 49 over 1, which is simply 49. It is now your turn to practice. I want you to look at these and try them. I'm going to pause the video. When you turn it back on, you will see that these are done, and I'll do a little explain. I am done, as you can see. The first one I rewrote right below each one. This is the work I should see on your paper, 1 over 36. 3 to the 0 is 1, 3 to the second is 9, answer is 9. In this one, if we're going to have no negative exponents, we always want to think of it as over 1, so the reciprocal is y to the third. Here, k to the 0 is 1, times 1 over k, making it a positive exponent by moving it in the denominator. Remember, it's always over 1 when you start, so our answer would be 1 over k to the second. Here's a couple that I think will give you some problems in your homework, so I just wanted to talk about those. I want you to think about this problem as actually negative 1 times 3 to the negative 2. That's all over 1, which means we're going to have 1 to make this positive. It moves to the denominator, 3 to the second, and our answer would be a negative 1/9. This is very much like 12, 15, and 17. Again, this one, negative 7 to the 0. It's like taking negative 1 times 7 to the 0, which is negative 1 times 1, which equals negative 1. Your homework that you were working on, be very careful that you're showing first. I want to see that you're making it a positive exponent and then putting your answer. Good luck, and we will take a look at your homework tomorrow and answer questions in class.